Hi, in this video we will do some examples for the orthogonal decomposition theorem. First, recall what does this orthogonal decomposition theorem says. It says that, well, for fix a subspace W of Rn, then for any vector v, there exist actually two vectors. One in W, there exists unique vectors, two unique vectors. One, let's call vector W in subspace W, and vector W perp in subspace W perp, such that the vector V can be written as sum of these two guys. Well, geometrically, this means that if you fix a subspace W, any vector you take in Rn, you will find a decomposition of this guy. One sum of vector W, another vector W perp. Well, sum means that these are like that, such that these two vectors are perpendicular or orthogonal. And while more, this guy belongs to W perp, that W itself is a vector in W. Okay, well, but how we find this thing? How to find W and W perp? Well, in another video we saw that this guys, there is one set of a pair of vectors that we can compute them when we fix an orthogonal basis for W. And when you compute those ones, since these vectors are going to be unique, the result is going to be what we are looking for. In other words, first fix an orthogonal basis for subspace W, then we'll use those elements of that orthogonal basis and find projection of V onto W. This is going to be our W vector, and our W perp vector is just perp of V over W. So you just need to fix an orthogonal basis. If the orthogonal basis is given, just go ahead, find projection, and find perp of V on W. You have found the vectors in the orthogonal decomposition of V with respect to W. Okay, let's see some examples here now. Here we have V is this, W is one-dimensional, 1, 1, everything is in R2. Well, when you have only one vector and the span of that one vector is W, then that one vector forms an orthogonal basis for W. And when you have that, you can just use it to find projection of V onto W, which in this case, we have only one vector, so it will be projection of V on that one vector U1, which is given by u1 1.0 plus 1.1 over 1 squared plus 1 squared, and then 1 1. And as you see, this is half times 1 1, which is half and half. This is our vector w. How about w perp, the other vector in the w perp? So that guy is perp of v over w, which is v minus projection of v onto w. In this case, v is 0 1 minus half half, which will give us negative half plus half. So we found the decomposition for v. V is sum of a unique vector in w and another vector in w perp. This guy is in w perp, this guy is in w. And this decomposition is called the orthogonal decomposition of v with respect to w. This other one, well, first thing to note that these two guys, if I call this one u1, this one u2, u1, u2 is an orthogonal basis for w. Oh, this w is not okay. Then we know that the vector w in the decomposition is nothing but projection of v onto subspace w, which is equal to sum of two projection of v on u1 and projection of v on u2. Well, projection of v on u1 is u1 dot v, 1 times 1 plus 0 times 2 plus 1 times 3, and u1 dot u1 is 1 squared plus 0 squared plus 1 squared, multiply to u1 plus u2 dot v, which is negative 2 times 1 plus 1 times 2 plus 2 times 3 over u2 dot u2, negative 2 squared plus 1 squared plus 2 squared. Then multiply to negative 2, 1, 2. That's u2. Well, let's see what we have here. So this is 0, numerator is 4, denominator is 2, so we will have just the whole thing, the coefficient here is 2. So 2, 0, 2 is what we have for the first part. And here what we have is these two cancel. This is 6 over 9. So this will give us 2 over 3, and you multiply, get negative 4 over 3, 2 over 3, and 4 over 3. And let's add these guys. 4 minus 4 over 3 is 6 minus 4, 2 over 3. This is 2 over 3, and this guy is 6 plus 4, 10 over 3. So we found this element which belongs to w, the subspace. How about the other element in the decomposition? We know that that is the perp vw, which is v minus projection of v onto w. Well, v here is 1, 2, 3 minus 2 over 3, 2 over 3, 10 over 3. And what this gives us, 1 minus 2 over 3 is 1 over 3. 2 minus 2 over 3 is 4 over 3. And this is 9 minus 10 over 3 is negative 1 over 3. Well, you see now we write b as sum of two vectors, one in this is in W, this is in W. And that's how we find the projection, the orthogonal decomposition of vector with respect to subspace.